Section 1.5, Analyzing Graphs of Functions. Motivation is what gets you started. Habit is what keeps you going. Jim Rohn. So first, let's look at the definitions. The graph of a function f is a collection of ordered pairs x, comma, f of x, such that x is in the domain of f. The x-intercepts of a function y equals f of x are the x values for which f of x equals 0. Another term used to represent zeros are roots, solutions, and zeros of a function. And we discussed this in the previous sections. So this is kind of a review of what we've been doing in the last 4 sections. Use the graph of the function to find the following. First, does the graph represent y as a function of x? So we can use a vertical line test. And so if I draw a line anywhere on my graph, I can see that it crosses in one point. So I would say that this is a function since it passes the vertical line test. Find the domain and the range of f. So the domain, again, are all the x values that are being used by this graph. So you can see that we start at -4, but we have an open circle. So that means that for -4, actually this is 1, 2, 3. For -3, we're going to use a parentheses because the point is not included. And then if we keep going across the x-axis, these points are being used all the way until we get to this x, which is 1, 2. If you notice at x equals 2, we are still part of the graph. And at x equals 2, we have a closed dot, so we use a bracket. The 5, for example, if we go up or down, doesn't touch the graph, so these numbers after 2 are not part of the domain. The range, we're looking at the y values. So all these y values here. So the smallest y value that is part of the graph is at 1, 2, 3, -4. So we use bracket -4, bracket because that point is included. And if we keep going up on the y-axis, we get to 5. 5 is also included. So we use a bracket for that. Find f of -1. So here your x is -1. And we're trying to find out what y is at x equals -1. So here's my -1. So I go up or down until I get to the graph. So if I go down, it touches the graph at this point, and that y value is 1, 2, 3, 4. So f of -1 is equal to -4. At f of 0, x is 0, I go down, and it touches the graph at -3. And at x equals -3, which is right here, it touches at 0, but notice we have an open circle. So we say this is undefined. And then f of 2 is here. If I go up to the graph, then I see that my y is 5. Find the zeros of f. Remember, the zeros are the x-intercepts. And all that means is where is the graph crossing the x-axis. So the x-axis is right here, and the graph is crossing at this point. So we say that the 0 is at x equals 1. And then here, although this is touching, it looks like it's touching the x-axis, since it's an open circle, it's not touching that point. The roots is just another name for zeros, and solutions is another name for zeros. So these are all the same point, just different names for it. So let's look at example 2 or letter B. Does the graph represent y as a function? If we draw a vertical line, it's going to pass a test. Even if we draw a vertical line here, this point is not included. So this would be yes, it is a function. Find the domain. So here we want to ask what are the x values that are being used. I'm going to go ahead and put an arrow to represent these lines extending to infinity. So for the domain, notice that all of these x's are being used. Okay, and this is going to go on to negative infinity. So we start with negative infinity, and then we keep going across, and you can see that all of these x's are being used because they land on top of the graph at some point. And it's also going to go to infinity. So again, the domain is all the x values that are being used. And then the range, we're going to look at the y values. So all of these values here. So if I pick any number here, I'm always going to fall on a graph, on the line. So all these values are being used. And up to here, these values are being used. But notice that past 2, if I was to go across, there's no graph. So my range is going to go from negative infinity, and then it's going to go up to 2, because that's the highest y value that's being used. And the 2 is an open circle, so I need a parentheses. So f of negative 2 is going to be f of negative 2 is going to be at negative 2 for x, we go down, and the graph touches negative 2. F of 0 f of 0 is right here, and so the y value is 0. F of 1, if we go up, it gives you 2 options, but again, this one is not included. So f of 1 is going to be 1. And then f of 3, if we go up, we're going to get 1. Find the zeros. Again, the zeros is where the x-axis, the graph crosses the x-axis, so that's going to be at this point. So at 0. Okay, so now we're going to look at another example. Example 3. Does a graph represent y as a function? Let me go ahead and add my arrows here. So if I use a vertical line test, then it does. So I'm going to say yes. Find the function values of f of 4. So here we have 1, 2, 3, 4. So we get 0. So I'm going to write b here. So f of 4 is equal to 0. And f of 1, if I go down, gives me negative 3. That was letter B. Letter C, find the domain. So what x values are being used? If you notice here, no matter what x I pick, I'm always going to be able to get on the graph. This extends forever. So I'm going to be able to get on the graph. So my domain will go from negative infinity to positive infinity. And my range, the lowest value here, the smallest value, is at this point, which is negative 4. And it's going to go up from negative 4 to infinity. Find the zeros of f. Those are the numbers where the graph crosses the x-axis. So this one has 2, and 1 is here, and 1 is here. So at x equals 0, we have a 0, and at x equals 4, we have a 0. F of x is equal to negative 4. So here, instead of giving me the number that represents x, they're giving us the number that represents y. So when y is negative 4, they want to know what is x. So here's my y, and that x value is going to be 2.